Hello everyone, welcome back to Spectrum classes, and in this video I am going to show you how this pH meter works and what are the important components of this pH meter. So here you can see in this picture, here is the display which suggests the pH value of the working solution. This is the working solution in the beaker in which potential of H ion concentration is determined by using this glass electrode, and this glass electrode is attached with the pH meter or outer assembly, and which is shown the value of the pH as 11.01. So before moving further or going into the details of this pH meter, I am just going to show you the schematic diagram of this pH meter. So here it is the working solution into which two electrodes are dipped. So one is the reference electrode and the other one is the pH electrode. Here you can see, and these two are connected with the pH meter. Here you can ask me that here you have shown two different electrodes, but here you are using just one electrode. Yes, you are right. So here is the combined electrode, which is the combination of these two, reference electrode plus pH electrode. So here I am just going to show you the picture of reference electrode here, and this is reference electrode 20. So these are the number specifications, and here is the glass pH electrode and it is given as GE15. So this is a special kind of glass which is used here to make this glass pH electrode, right? So here is the reference electrode. I am showing you, this is the refilling tube and here it is in solution. Actually it is not functioning for several years, so just for the sake of the structure of this reference electrode I am showing it here. And here is the glass pH electrode. It is having this safety cap, and first we are going to remove this, and now I am showing it to you. So here you can see only one electrode is there which is kept inside the internal buffer. So this is silver chloride electrode, and this is dipped in the 1 molar concentration of HCl solution. You can see here. I am just giving you a brief introduction about the reference electrodes. So these reference electrodes are of two types. One is primary reference electrode and the second one is secondary reference electrode. So this standard hydrogen electrode is used as primary reference electrode because its potential is arbitrarily set at zero potential, and therefore with respect to this standard hydrogen electrode we are measuring the other electrode potentials, whether they are oxidizing or reducing, and on that basis of their reduction electrode potentials electrochemical series is defined. So this question may be asked, if we are having this standard hydrogen electrode, then what is the need of having this secondary reference electrode? And the answer is that because in the standard hydrogen electrode we need to maintain 1 atmospheric pressure of hydrogen gas, which is not convenient for each of us to maintain in the laboratory. Therefore, instead of using this standard hydrogen electrode, we are using other standard electrodes whose potential is known, and we are using them as secondary reference electrode. The two common secondary reference electrodes are calomel electrode, which is represented or abbreviated as SCE. Here it is SHE and here it is SCE. And the other one is silver chloride electrode. Their compositions or cell representation is given like this. This is mercury and this is mercurous chloride solid in 1 normal KCl solution, and its potential with respect to this SHE is minus 0.2800 volts at 25 degrees centigrade. Whereas for silver chloride electrode we are having this silver and silver chloride solid which is dipped in HCl solution where activity of Cl minus is 1 normal. Then the electrode potential with respect to this SHE we are having minus 0.28 2224 volts at 25 degrees centigrade. So since mercury is toxic in nature, therefore silver chloride electrode is very commonly used as secondary reference electrode. Now you see the values at 1 normal or 1 normal for this calomel electrode and for this silver chloride electrode. Now I am showing you here the values if we change the concentration of their solutions. So here KCl in saturated, again saturated, the values change. Therefore, rather than using the concentration of H plus ions, we are using the activity. Now I am showing you the schematic diagram for this reference electrode, and here is the refilling opening through which we can refill saturated KCl solution, and here is the reference element. This KCl is known as electrolyte, and here is the junction through which this reference electrode is in contact with the working solution. And the important point about this reference electrode is that the reference electrode must have a defined stable potential which is independent of the measured solution. Now the glass electrode. This glass electrode consists of thin glass bulb. This glass bulb is there, and here is the sensing electrode. That is why it is known as glass electrode. It is containing a fixed concentration of HCl solution. This is the shielding. This is the element or electrode of fixed potential. This is the inner buffer, that is the H ion concentration or HCl solution, and here is the membrane. The important point about this glass electrode is that this glass bulb is made up of very special kind of glass which is known as Corning 015. So here you can see glass electrode 15. So this is representing this Corning glass, and the composition of this Corning glass is about 75% SiO2, 22% Na2O and 6% calcium oxide. It has a relatively low melting point and very high electrical conductivity. That is why this glass is used, right? So this is the importance about this glass electrode, and we generally use silver chloride electrode inside this glass electrode, and in which the HCl concentration is 0.1 normal. The inner electrode, this electrode is of this glass electrode system serving to make the electrical connection with the outer circuit, and it is represented like this. So silver chloride, how this silver chloride solid, because we have only silver and this HCl. So from where this silver chloride solid comes, actually here we are having this silver, it is producing silver plus electron, and this silver plus on reaction with HCl, it forms half H2 gas plus on absorbing this electron plus AgCl, and this AgCl, as you know, it is a precipitate. So precipitates are represented by this solid, right? So this HCl is important here. So that is why we are having this silver and this silver chloride solid, and here is the 0.1 normal HCl, and here is the glass membrane, this glass membrane. Inside this cell, it is the composition, right? This is the composition, this is the glass membrane, and here is the experimental solution. Outside this circuit we are having the experimental solution, right? So this is like a concentration cell.